So what we've talked about so far is a structure that looks like this. We have a linked list, which has a series of nodes, which are made up of cargo and a next value. And that next value points to the next item, or next node in the actual list. This is what we call a singly linked list. It's not the only type of linked list. In fact, there are many other types. Well, just briefly to give a quick overview, there's also something called a doubly linked list. And as you might surmise, it looks very similar with one small difference. A doubly linked list doesn't just keep track of the next value. So it has the next value, which points to the next node, of course. We like to break this off, kind of something like this. But it also has a previous. And that one, for the head, will point to null, of course. But for the other ones, will point to the one that pointed to it. What this allows us to do is set up a system where we can actually communicate back and forth. We can go up and down the line. It makes searching potentially a little bit easier, or there might be some mechanism that you need to do that you're in the middle of processing. You might need to go back and forth, back and forth, back and forth. So for example, when you want to delete the tail, you have to do some special checking to make sure that you don't go past the end of the list, and then go back to the second last one, and then delete that, and then delete the next value. But the problem is you need to do some special if checking to make sure you don't get too far. Well, if you had a doubly linked list, you could just go to the end, take a step back, and then delete that node. You wouldn't have to worry about it anymore. With doubly linked lists, it does make certain things like insertions and deletions a little bit more complex, because you have to make sure that all your arrows are pointing to the right location. So for example, if I want to insert a new one here, this guy would point here, and this guy would point here. Where does he point? Well, he points down there, and he points down there. So you have to make sure that, and then those connections go away. You have to do double the amount of connections. And there is one last one, let me just get rid of all this stuff, called a Circly linked list. Circly, yeah, I don't think it's really a word, but that's what it's called. Circly linked list. And I'm just going to draw 3 nodes, just to make a point. We know that this one points to this one, and traditionally this one points to null, because this is the tail. This is the head. But in a Circly linked list, this is not the case. In a Circly linked list, it comes down and it points back to the head. So we've created a structure, a circle structure. So there is no real end. There is still a tail designate, but it really has a lot less meaning at this point. So you have to be very careful, but this does allow you to loop back around back to the beginning, and again, depending on whether you need that data. So that is the other forms of linked lists that are really important at this point. There are others, but that's all that matters.